Okay, I welcome you all once again to the next assignment session 11 on the NPTEL course Engineering Hydrology. I am here presenting my screen. Kindly let me know whether it is visible to you or not. Also confirm the audio. Ashish, can you tell me whether this screen is visible to you and my voice is audible?
Yeah, it's visible.
Okay. Okay, so in today's session, we are going to discuss some of the problems and concepts related to hydrologic statistics, where we will be covering the basic descriptive statistics that is used to represent the hydrological data. Then we will also look into the concept of frequency analysis related to different time series of data for rainfall or flood discharge, and also we will try to establish the extreme variation related to the observed hydrological data. So today we will start our discussion with the question given as follows. So here the question is, out of the following, the discrete random variable is. So it is asking about a random variable. It should be a there should be a variability involved in the parameter. Okay. So we in that sense, you can say if I'm saying that I'm having 1 to 10 10 number of data, and I'm not saying that it is uniform. Okay, it could be anything between 1 to 10, like it could be an integer, or integer in terms of it could be a decimal value as well. So I'm saying that the variability is uncertain to me. I can't say that yes, it should be like 1, 2, 3, 4, 5, or it should be like 1 or 1.25 or 1.335, or maybe it may be in certain values. It could be like in terms of fraction, which is not it is irrational type of thing. Okay, so in this regard, the variability most common variability you can find in which kind of option. Okay, so here the options are temperature. Okay, so temperature in the sense, it could be an absolute value of temperature, it could be in that term. Okay, then there is another parameter like annual rainfall, so it will again have an absolute value of overall averaged value of over 365 days. Okay, and then again you are having another parameter called annual runoff, then again it will be a absolute value over 365 days. So you are getting a single absolute value, but still out of 365 days there is no discussion related to the variability within 365 days. So we can't actually say that it is a random variable. It's just a absolute value only. Okay, so temperature will also it could also have an absolute value over the days or maybe over a month. Okay, But if it is there is a one last option mentioned here, number of rainy days. Okay, so in this case, like uncertainty is there because we are counting the days now. Okay, like what like out of 30 days, I cannot say or I cannot predict that in the coming 7 days I will be having this much of an intensity of rainfall. Okay, so uncertainty is involved in this, but in other parameters A, B, C, we cannot justify in the correct manner. So here the uncertainty will be uncertainty in the terms you should understand in terms of probability. Okay, so probability associated with the number of rainy days will be more random as compared to the absolute value we are having. Absolute value mean in the sense it is an average value over 365 days. So in this case we are not getting a random variation between individual days, but if we consider this parameter number of rainy days, we will be having more understanding, more detailed observation about the rainfall scenario between days. So this parameter will be best explaining the discrete random variation. We will discuss this concept while we are dealing with the problem related to frequency analysis. That will give you a more clear understanding on this. Okay, so some of the key information related to random variable. So variable which can assume any value within a certain range. So yes, it is talking about a range. Okay, range in the sense if I am saying that rainfall could be could occur between like 15th of April to 13th of April. Okay, so now I'm talking about a range, but between this range I'm not sure, uncertainty is there, and that uncertainty will be measured in terms of probability. Okay, that is why we are here and discussing the statistics of hydrology. So yes, it is mentioned in the next line that probability distribution should be assessed in order to quantify the random variability related to hydrological parameters. And how we can assess that probability? So probability of a random variable having a value less than or equivalent to a specified value can be assessed in this term. And here it is mentioned that x is a variable, any kind of variable it could be. Okay, now we are heading to the next hydrological statistical distribution. So the question related to that is that the symmetry of distribution about the mean is measured by. Okay, so if we are having a data, any kind of hydrological data, and we want to get an idea about the symmetry in the sense what it should be measured in terms of any kind of specified value. You can say if I'm taking it as a mean value, if I'm saying that for an example I'm having a time series data of rainfall. Okay, and rainfall for what period? 1990, that is a year, to 2024. I'm having rainfall data of this much, and that scale is given to us, that is a daily scale. Okay, now I'm having the data. So you will be having a data for it is in a daily scale, so you will be having a 365 days for each year, or maybe if it is a leap year it will be like 366 days as well. Now out of these data you are now computing the average annual rainfall. so that will be a mean value. So if I am saying that if the mean value is coming to be 350 mm of rainfall, it is coming. Now there may be some other values which may have the distribution different from mean, okay, and that distribution could be in the form of probability distribution. It will be following any kind of probability distribution. There are one famous probability distribution called Gaussian distribution. Some people also use exponential distribution, then gamma distribution is also there. We will see these distribution in order to fit these time series data through these curves. We are defining the data using these curves so that we could have better understanding that how these data is behaving. So now if I am saying that what should be the symmetry, okay, if I want to measure the symmetry of, if I am plotting this entire rainfall data and I am getting a curve like this, it is not possible that it is not always possible that I am getting a symmetry only. It could be possible that mean will be like it will be passing from here at this point, or it may be possible that mean is going like this. So in that case we will be defining the symmetry of distribution. So which parameter is essential for defining the symmetry of distribution about the mean? So the options are standard deviation, then the variance is there, then coefficient of variation, and coefficient of skewness.
It's a standard deviation.
Yes, it's a standard deviation, and it is represented by sigma. Okay, and it's also having a formula of square root of summation x minus x bar to the whole square upon n minus 1. That is the number of observations I am having. Then x is what? X is a value of magnitude of the rainfall event at any day, and x bar is what? That is a mean value. Okay, so using this, we already used this formula while we were checking the optimal number of rain
No rain
gauges.
gauges. Yeah,
Yes, right.
correct.
So we have already used this. Okay, so here it is mentioned again that how we can measure the symmetry. So it represents the symmetry of distribution about the mean. And how we are getting this? So it's a third moment about the mean. It's called a third moment. Okay, then if we are measuring the, wait a minute, I guess it should be, if we are about to measure a symmetry, then it should be like skewness, not a standard deviation. A deviation will be a part of variance. Okay, it will be measuring a variance associated with the data. But if we are talking about the symmetry, then this coefficient of skewness, that is a skewness, we have to check it. So here the answer should be coefficient of skewness. It is like a standard deviation is much more representing the variance in variance related data. Okay, so various kind of information can be depicted using a standard deviation, but coefficient of skewness is defining the symmetry of the distribution. So if we are talking about the symmetry, then yes, symmetry could be going in positive direction. So positively, if it is going positively skewed, then we are determining this coefficient of skewness, that is a C. Okay, so see how we are determining. So we are having a third moment about the mean, and we are defining the number of observation values we are having. Then after computing C value, if it is greater than 0, it could be found that it is positively skewed, and moving towards the y-axis, more towards the y-axis. But if it is negatively skewed, it is going away from the y-axis. Okay, So from this curve you can see that it is going away. Okay, so distribution is positively skewed when there is a high number of large data. Okay, and distribution is negatively skewed when there is a higher number of smaller data. So these things you should have in your mind, that negatively the data will be negatively skewed with small data as compared to the large data. Which of the following statements are correct about the standard deviation? Okay, so now the question related to standard deviation that we have discussed in the previous concept, we were discussing on this topic only. So the options are: the larger the sigma, that is the standard deviation symbol, the larger is the spread of the data. Okay, so if I am plotting a distribution like this, and there could be a possibility that this curve will be plotted like this also, and there could also be a probability that this curve could be going like this also. Okay, so this is a, you can say this is a mean value. So where we are getting a mean value, then after this we are getting plus of sigma. It may be possible that it may be going for some delta sigma as well, and in the opposite direction it will be minus sigma, and then minus sigma uh, plus delta sigma, and then so on. Okay, so this is representing the spread of the data, but the options are as larger the sigma, we are saying that it is having a large spread of data, and then it is also measuring the variability at the same time, and it could be expressed in the terms of square root of variance. Okay, square root of variance. So this, so whatever variance is there, that is what we have discussed at in that formula, x minus x bar to the whole square upon n minus 1. Okay, and then other last option is all the correct. So you may have already have studied this topic, standard deviation, in earlier uh, like uh, in class 10th or 11th statics. We already have some idea related to this.
Yes, yes. It's. I think it's all are correct.
All are correct, yes. So Ashish, you are right. So here standard deviation will represent the spread of data. Okay, from this picture you can have better understanding, and then it is measuring the variability, and it could be expressed in terms of square root of variance. So yes, the whatever the discussion we did so far, it is the same as mentioned here. So it is measuring a variability and calculated by using this formula, so square root of variance, and also it is sometimes called as a shape parameter. Larger the standard deviation, then larger is the spread of data, and then here you will find a one word called PDF. PDF is nothing but probability distribution.
Frequency.
Probability, yes, probability distribution. Frequency. So here from this curve you can say that this graph is having more standard deviation or the spread of data as compared to the upper curve which is given. Okay, coming to the similar topic related to skewness. So just now we have discussed that skewness is what it is representing. It is representing a symmetry.
Symmetry. Yes.
Okay, symmetry of the any kind of probability distribution. Okay, so skewness is representing a this symmetry, and how we can compute that. So options are as follows: first movement about the origin for the distribution, then second movement about the origin for the distribution, first movement about the mean for distribution and third movement about the mean for the distribution. Do you know like the meaning of first option, if it is saying that first movement about the origin for the distribution? It is nothing but it is a mean. Okay, whenever we are talking about a first movement about the origin, then it is called a mean.
Okay.
Okay, and if we are talking that if we are taking a second movement, okay, second movement about the origin, then it is expressed as you can say a variance. Okay, and then if we are trying to compute the third movement about the mean, then we can compute directly the skewness, that is a symmetry. Okay, just now you have seen that this coefficient of skewness. Okay, so how you are getting this part? So it is mentioned here that this skewness represents the symmetry of the distribution about mean and quantifies the skewness. And how it is quantifying? So we are taking the third moment about the mean. And how it is taking? So you can see that there is a x, that is a random variable at, or maybe any event value at which is occurring at any time interval, and then mu is a mean value. Okay, and if we are taking the integral of this entire, if I am having a PDF, any kind of probability distribution curve, and I am taking a some small segment of this, okay, I am calling it as fx dx. Okay, if it is having a dx width, and I am integrating it from minus infinity to positive infinity, having its provided its mean mu value. So I can directly achieve the third movement about the mean, and which is nothing but skewness. So for achieving this the idea of symmetry, we should compute the coefficient of skewness first. So we should have this value, and then we can judge according to these parameters, like whether it is positive skewness, like depending on the value, it is greater or greater than 0 or less than 0. Okay, now question is related to a dispersion. So measure of dispersion is, so dispersion in the sense you can say that it is nothing but it is just a spread of data only. Okay, dispersion will be what? In its meaning you can say like it is an spread of data. So it is
Okay.
talking about how the data is getting spread.
Hmm.
Okay, so how you can measure this? So we have just discussed that what parameters can do, which parameter can define the spread of data.
Variance.
Yes, variance, and if we are having a variance, then there is a relation between variance and standard deviation. Both are defining the spread of data only, right?
Okay.
Yes. And standard deviation is we already seen in one question
Hmm.
that it is a square root of variance, right?
Okay.
Yeah. And then I just mentioned that what is skewness?
Symmetry.
Yes, it is representing a symmetry. Okay, and then if I'm talking about the kurtosis, so kurtosis is a parameter representing the peakness, how peak the probability distribution can go. So it is representing a peakness of probability distribution curve. We will see it later. So here for time being, the options are standard deviation and variance. Okay,
Hmm.
yeah. Okay, so here you can see that how we are measuring the dispersion. So dispersion of any data we are having, so it's a measure of spread around its central value. Okay, so variance will be representing a variability of data or the spread about the mean, and it is measured as a second movement about the mean, what we have just studied that time. So if I'm saying that mean, so it is a first movement about the origin, right? But if I am saying that variance,
Second movement.
yes, then it is a second movement about mean, because now we have mean, now we will be computing other parameter based on this reference. So second movement about mean, and then if we are computing the third movement, then what will it called?
Symmetry.
Yeah, symmetry measured in terms of skewness,
Skewness.
right? So third movement about mean. Okay, now there is question related to a kind of probability distribution. So here that probability distribution considered here is exponential distribution. Okay, the question is related to exponential probability distribution curve. See, there are many kind of probability distribution curve, depending on the what type of data we have. Sometimes if we are dealing with the flood kind of data, flood discharge, if we are trying to quantify, then at that case Gumbel kind of distribution curve is mostly used, extreme Gumbel distribution. There are many type of versions related to Gumbel distribution as well. Then there are distribution curve given by gamma, then exponential distribution is there, then Gaussian distribution is also there. So depending on the what kind of data or what kind of result we are looking for, we need to fit these data in these probability distribution curve, and then we can have more idea about that how this data is going, like with the time it is going or with the space it is going on. So here in exponential distribution, there is a relation between lambda, that is one of the parameter representing the property of exponential distribution, and other parameter is mu, that is a first movement about the origin. So relation between both these parameter lambda and mu, what what type of relation it this probability distribution curve gave for these parameters. So whether this is equivalent, whether it is it is a square, okay, mu of a square, okay, don't confuse with this. And then there is one my mu, and then there is again one parameter called 1 upon mu square, that is a square root of mean, this square of mean. So any idea, have you seen this probability distribution curve while going through lectures?
One minute. Balamurugan says it's lambda is equal to 1 upon mean.
Yes, so it's having a reciprocal or indirect relation between lambda and mu. So Balamurgan is right. Good. So how this exponential distribution is expressed? So this exponential distribution is used to determine the length of time interval between occurrences of event. Okay, so it is focusing more on determining the time of occurring an event. Okay, so if event is happening, then what could be the like interval, in the sense, if I am saying that a flood is happening with a return period of 60 years. Okay, so this return period if I'm saying that this flood, if I'm designing any kind of hydraulic structure, there is a need of it's like sustaining life, how much life it can sustain. If there is a condition that flood of, maybe I'm saying that 50 cubic, okay, it can occur with a return period of 60 years. So if I'm saying that it is a 60 years, then this is a length of time, okay, that if this flood of this much of value is coming after 60 years, then there is a risk associated with this hydraulic structure, because it is not going to hold this much of amount. Maybe this much it can hold, but if it is exceeding with a little much value, then this is not having that much strength in that case. So there are parameters lambda, and in order to quantify this lambda, there is a relation established with mean as well as a variance. You can see here. So variance is also equivalent to 1 upon lambda square. So here you can take the time interval that is representing it as a lambda. That is a parameter representing the time domain. Okay. Okay, there are some questions, numerical questions related to probability, directly related to probability. There won't be like a hard and fast rule. We already studied the probability concept in our earlier classes, like in 10th or 12th. So we could solve easily. So here the question is given that historical data of an area shows that probability of occurrence of a flood given that landslide has already occurred in a particular is 0.3. So for this case, probability of occurrence of a flood, you can assume it as A. Okay, if I am assuming it as A, then probability of occurrence of a flood A, of flood represented by symbol A, that is given here 0.3. Okay, now the second aspect is given here, probability that landslide will occur given that flood has occurred is 0.8. okay, so the probability that landslide will occur given that flood has already occurred is 0.8. Don't you think it is a kind of conditional probability? Already one thing had been defined, okay, and we are given the probability of other aspect based on some kind of reference. Okay, so if you have an idea related to conditional probability, so conditional probability in that case, during our classes we have studied that if probability related to a kind of event A, when already B event have been occurred, is represented by P upon A by B, some kind of this. So here you can consider that probability of occurring, like probability that this landslide will occur given that flood has already occurred. Okay, so here it will be in the form of ratio, this ratio 0.8. okay, there may be possibility that this A should be maybe in the denominator. Don't you think, Ashish? What should be the representation? See, flood will be represented by A, and if we are taking that landslide in the year B, then how we will represent this?
So P upon B is equal to 0.8, na?
B upon A. Let's
B
see.
upon A.
Okay, for time being we are considering this. We will see in the explanation. Okay, now there is one more parameter given, that joint probability.
B upon A, sorry.
Okay, so this joint probability will be A intersection of B.
Hmm.
Okay, joint probability of flood as well as a slide. It is a landslide. It is given as 0.2. Now the question is, we want to determine the probability of occurrence of a flood A. Okay. So here probability of occurrence of a flood A, given that, okay, there is one more thing we have skipped in that case also. It is mentioned that probability of occurrence of a flood given that landslide has already occurred. So it is again a ratio of A by B. It is not A. So it is 0.3. Now question is related to, we want to figure out probability of A and then probability of B. Both things we want to quantify.
P A upon B is equal to
Read
0.
that question easily. There is take your time and see if we are about to solve a problem related to conditional probability, then any kind of event which is occurring with reference to a event that has already occurred, that is represented by p equal to p a by b, it could be expressed in the form of P A intersection B, that is a joint probability, upon P upon B. This is a relation, if you are remembering that. See here also it is mentioned in the this conditional probability part, that if we are if we are about to solve P A by B with the condition, then it could be expressed as a intersection of P of A by B and then with ratio of reference value. Okay, so how we can find this value P by PB? Okay, if in case we are about to solve. Okay, so here also what other things have been assumed? So P of A it is given, P of B we have taken.
Hmm.
So P of AB, okay, what we were taking, P of AB,
0,
yes, we are also right. Yeah,
0.3
and then it is 0.8,
B upon A.
right. So
Hmm.
now if we got this relation, now tell me how we can compute PB. Tell me the value. We already have P A by B value, right? It is given 0.3.
Hmm. Hmm.
So 0.3 we already have. Then we have intersection value P of A intersection B, that is 0.2, and then P of B. How much value it will be coming?
0.2 divided by 0.3. 0.66.
0.66. Okay, we will check it. And then for the PB you can also replace the things, like instead of P of A by B you can take P of B by A, and keep in mind that this whatever the joint probability is given, it will be equivalent only. Like if we are writing that P of A intersection B or P of like
B intersection A.
yeah, A intersection B, or if I'm writing as B intersection A, it is the same equivalent value.
Equal. Okay, yeah,
Yeah,
yeah.
so take this value as same and then try to figure out that value. So yes, Ashish, you are right. Whatever the value you are getting for PB, it is coming 0.667. Now tell the value of PA.
PA is 0.3 divided by.
So what was P by A? P by A we were having, that is equivalent to 0.8 value. So you have to take this value 0.8.
0.375.
Point,
375.
no, it is coming
Hmm.
0.25.
Sorry. Yeah, it's 0.2. No, earlier. The joint probability is 0.3. No, no, it's 0.2. Okay, okay.
Yeah, see, yeah,
Yep. Sorry.
yeah.
सर मैंने यहाँ पर PhD में अप्लाई किया है.
Okay.
So I just wanted to know like the way of approaching a professor and something. और यहाँ काम
एक्चुअली फॉर टाइम बिंग ये ग्राउंड वाटर लैब है, तो इस पे जो इसके इंचार्ज हैं तो वो प्रोफेसर ब्रिजेश कुमार यादव हैं, अभी करेंटली अब्रॉड हैं वो कॉन्फ्रेंस के पर्पज से।
ओके.
तो आपने किस प्रोफेसर को अप्लाई किया?
अभी तो कहीं नहीं, डिपार्टमेंट में सिर्फ एप्लीकेशन फॉर्म डाला है.
ओके,
सो आई जस्ट वांटेड टू नो कि मतलब किस प्रोफेसर को अप्रोच करना सही रहेगा और उस चीज़ का.
आपके इंटरेस्ट के ऊपर आता है पहले तो आप
मैं वेस्ट वाटर में काम करना चाहती हूँ.
वेस्ट वाटर पे काम, तो देखिए आप भी करंट में यहाँ पे वेस्ट वाटर पे दो प्रोफेसर काम कर रहे हैं। एक तो डॉक्टर ब्रजेश यादव है जो इस ग्राउंड वाटर लैब में इंचार्ज हैं अभी, एंड देन एक डॉक्टर नितिन खंडेलवाल हैं नितिन खंडेलवाल, यस। तो ये भी अभी करेंटली वाटर क्वालिटी ये वेस्ट वाटर पे इनका इफेक्टिवली काम हो रहा है। तो साथ में जो हमारे प्रोफेसर ब्रजेश यादव हैं तो उनके अंडर पे एक इंस्पायर फैकल्टी हैं, ही इज़ ऑल्सो फैकल्टी एंड ही इज़ ऑलरेडी हैंडलिंग 1 or 2 PhD स्टूडेंट्स।
ओके
बट वो ऐसा है कि वो जॉइंट सुपरविजन पे चल रहा है क्योंकि वो सर के अंडर पे ही इंस्पायर फैकल्टी है।
ओके
तो आप उनसे, तो मेरे को लगता है मेनली आप ये दोनों को ही अप्रोच करेंगे तो शायद
ज़्यादा बेटर है।
यस।
तो मतलब इन्हें अप्रोच करने के लिए नॉर्मल एक फॉर्मल मेल डालूँ ना, जैसे फेस टू फेस बात कर लेंगे, क्योंकि मैं यही हूँ, लाइक सिविल डिपार्टमेंट में मैं प्रोजेक्ट में एनरोल हूँ। सो इट्स
आप
क्वाइट
अभी
इजी।
पहले फॉर्मल मेल लिख सकते हैं जब तक वो अभी यहाँ पे नहीं है। लेट हिम रिप्लाई फर्स्ट,
ओके
ओके, वॉट एवर द ही इज थिंकिंग क्या होगा, और आप अपने इंटरेस्ट एरिया को भी उसमें मेंशन करिए कि यू आर विलिंग टू डू दिस काइंड ऑफ वर्क, ओके।
और
और
नितिन सर तो यही होंगे।
ये होंगे बट आई गेस आई डोंट थिंक अभी होंगे।
नहीं नहीं, वो तो बाद में मिल लूंगी मैं।
हाँ हाँ हाँ
उन्हें भी एक मेल
हाँ,
डाल
आप
दें,
उनसे भी कर सकते हो, राइट।
है ना?
यदि आप एक्चुअल में होता ये है कि फर्स्टली आपको ना उनके प्रोफाइल पे आप जाओ एंड देन लुक एट वॉट एवर द वर्क ही इज डूइंग एंड देन अकॉर्डिंगली यू हैव टू मेल देम एंड देन वो अपने से खुद ही बताएंगे अप्रोच करके कि क्या ये चीज़ हम कर सकते हैं साथ में या नहीं।
लाइक मेरा नेट क्वालिफाई है बट जेआरएफ नहीं है, सो इट्स लाइक कि वो क्योंकि जेआरएफ नहीं है इसलिए रिजेक्ट तो नहीं कर देंगे ना?
नहीं, JRF, देर आर सम पीपल ऑलरेडी वर्किंग फ्रॉम JRF ओनली, लाइक नेट किया है तो
ऐसे उसको
MSc
इंस्टीट्यूट स्कॉलरशिप मिल जाती है जिनका नेट हुआ रहता है,
हाँ।
और जेआरएफ इज लाइक कि वो सेंटर
there
से
are
फंडेड
1 or 2 people working
As net वाले।
yes,
Okay.
so you can discuss, there is like Shruti is there,
Okay.
one of student working under British only,
Okay.
so you can contact
Like can I have your number so that I can
yes, you can take.
your good name?
Prabhat. So we can discuss more later because right now I am having class.
Like I am giving you call. My name is Aina.
Okay, yeah, sure. Yeah, I got your call. Thank you.
Thank you sir.
Yeah. Okay. Hello. Sorry for the disturbance.
Yeah, it's okay.
Yeah. Okay, so Ashish, you got this answer?
Yeah, 0.25 I got.
Okay, good. So whatever, okay, we already got 0.667. So that means probability of occurrence of a landslide is of about 66% against the probability of occurrence of flood. Flood is about having a probability of occurrence of about 25%. So which one is more severe? So landslide problem in that area, whatever the data, historical data is given here, and based on this data, we can say that landslide problem is more severe. This area is more prone to landslide against flood. Okay. Okay, now we are moving to the question related to the annual flood series data. So if we are having, we already maybe having a outlet of the catchment, or maybe you can say there are many stream gauging stations. Okay. So now I am having a stream gauging station. Can you tell me what kind of data I can get from stream gauging station? What kind of data, what from your understanding, if there is any kind of station or gauging have been made at any cross section of the river, then what kind of data CWC or maybe any private organization may be recording, and that could be helpful for both purpose, like a hydrological purpose as well and hydraulic purpose. Okay, we already studied these concepts,
Yes.
hydraulic routing as well as hydrologic routing. Okay, so what kind of data do you, what, from your observation, what do you think, what kind of data?
So we get the steam flow data
Yeah, right,
and the depth of the we can say variance in the depth,
right. So a depth of you are saying that water table. Okay,
water table.
uh,
Yes.
okay, then what is I got this, then this will be water surface. Okay, then what next? So you are saying that we are having this kind of cross section along a river, and I could have, see, the thing is like whatever you are saying that there should be certain water surface, okay, river water level, okay, and now you are saying that I should have a depth measurement, okay, in this way. Are you saying that this only?
Mm-hmm.
Yes. So now you are right. So we are, what we are doing is that we are measuring, like not actually from my side I also already did this kind of measurement in the field. I already went into the field and I measured this a river discharge using a current emitter. So for that case what I did, so in the current emitter assembly we have one, like you can say a cup kind of phenomena, okay, that is moving, that could rotate with the current of water that is there. So water current may be there, and in that case, like water current in the field, that is a velocity. So that velocity will be rotating these cups, and we will be recording a number of revolution of these cup. Okay, and we are doing at every step. Like if I am saying that this river is of about 30 meters, okay, now how you can say that result will be more finer, finer, or in the sense that is more accurate. So if you are taking this measurement, this number of revolution or maybe a velocity measurement at shorter span of this length, okay. So if I say that I have divided in 1 meter, I have divided in 1 meter and 1 meter, so on. So I will, what I will be getting, I will be getting a velocity. How we will be getting a velocity? So this number of revolution will be converted to the velocity directly. How? So there is one direct empirical relation, or that is a calibrated relation, which come up with the instrument as only. So there is one relation, that is a n plus of b. So these a and b, these are the coefficient for what, for this instrument, okay, that is already calibrated. So only putting this, only giving the number of revolution to this formula, I can directly get a velocity. Okay, once I get the velocity, I am having the idea of velocity. How I can get the discharge of this section? So for that you should have the idea of, firstly, width. How much width you are targeting? So if you are targeting a 1 meter of depth, 1 meter of width, and then at the same time you are measuring the depth of water level, okay. So now you can say, for time being, if you assume that this area will nearly establishing a rectangular kind of this shape, though it is not always possible, but in that case there are many trapezoidal formula, or many polygonal based formulas are there which we can use if we want an accurate area. But here for time being, if I am assuming that area is rectangular, then area will be multiplied, that will be a length into width, okay, and simply I will be getting an area. Now this area, it will multiplied by a velocity, I can directly get a q, that is a discharge. So this discharge is being measured at every day, okay, and they are providing. So in that case you are getting everything na, that they are measuring the depth of water table also. So one parameter they have measured, and then they are measuring the velocity, that is important, and based on that they are giving the direct value of Q. So mostly during the monsoon period, this measurement is being made by CWC official in very accurate manner, or because why, because continuous water which is coming like falling in the remote area is directly meeting into the river, and so volume is more high. So in that case this data is being given to us. Now that data, based on that data only, this whatever question you are looking at, this question have been framed. Okay, so after analyzing the discharge data, so that discharge is being called as annual flood series. Okay, so for every 365 days, one peak value have been considered, okay, of a river yielded a sample mean. Now for entire that data we are getting a mean value. Okay, so I am having a mean value, so this is, I am representing it as x bar. So x bar is given to us, that is 1000 meter cube per second. Then standard deviation is given. For this data, how, like if there could be any kind of distribution have been established for this data, and it have been found that from the mean how much it is deviating, or in order to get the idea that what is the spread of this data. Okay, so for that case standard deviation data have been measured, so that is sigma we can say, and that is 500 meter cube per second. And now the question is estimate the design flood of the structure. Now see that this problem is more related to a field aspect. Okay, now you can see that we want to construct any kind of either reservoir, or maybe any kind of if we want to divert, say take an example of barrage, or maybe weir or barrage. Sometimes we used to make this small kind of a structure in order to divert the water for this irrigation purpose. Okay, so instead of making a big reservoir, we used to sometimes like engineer prefer to make weir or barrage in order to divert surplus amount of water for irrigation purpose. So you can assume these kind of structure. And now what the things we have to provide in advance is that whatever the construction engineer, or maybe any kind of person, stakeholders you can say, so that though they are asking from you that we want 90% assurance that this structure won't fail in the coming next 50 years. Okay, so if this assurance is needed, for that case we should have idea related to return period. Okay, now it also been mentioned that for this problem you can use the Gumbel's method, and you can assume that this sample size is very large. Okay, so this question is more related to a field aspect. Okay, you got every data with you, and now you have to, so you should tell me that what kind of approach we should make. Do you have an idea related to Gumbel's method? Any kind of relation do you know related to Gumbel's method? There is one famous relation based on that this Gumbel method works. So that is xt equals x bar plus sigma k into sigma. Do you remember from your lectures? You could have this idea that this is the representation for Gumbel's method. So now see what they are asking from us is that design flood of a structure. Okay, so that we can assume it as xt in the sense that is a design flood. Okay, for the target whatever the target we are given to us. Okay, or maybe any time period of return period of t. Now that is equivalent to x bar. X bar is what? That is a mean value. So we already have this data, and this sigma is standard deviation. We already have this data also, 500 meter cube per second. Now what left? What data is still missing? And with that data we can compute the xt value directly.
Yeah. Can you please explain the flood return period? I didn't get it.
What?
The return period. What you said?
Yeah, but that return period is basically, it is represented by this frequency factor k. So basically in this entire question, this relation, k is only missing, right? So if we have idea related to k, that how we can compute this k value, so we can directly compute xt, right? So here this k value is called frequency factor, and it is dependent on return period. You are right, that is the return period. It is this has a relation with return period. Okay, got it?
Return period means in 50 years frequency of flood return.
Yes, right, exactly. So in that case, whatever the assurance it is asking, so it means that they want reliability. Okay, so you may have during your lectures you may have studied two major words, that is, one is risk and the another one is reliability. So if they are asking for 90% assurance, that means it is a reliability. Okay, and if we subtract from 100, then it is 10% risk they are they are looking for. Okay, so this is the thing. This question is it's saying. So how we can compute this k value? Any idea? Any relation? Do you know?
No.
Okay, wait a minute. I guess this. Let me check it. Yeah. Wait a minute. Okay. Let me see. What was the question given to us? Wait. What is the direct question? 90%. Okay. Somewhere its explanation have been switched in the slides. Let me confirm first. Okay, so from here I can tell you directly. See, we want to compute k factor, right? So we need an idea related to k. So I'm just showing you one of the relation directly. Yes, from here you can see directly. Okay, so here see, just for your information only, I'm showing you this. So from here, this relation you are well aware of, that xt can be computed using x bar plus k sigma n minus 1. We have already discussed. Sigma is standard deviation which can be computed like this, but for this question we already have the values with us. K K is a frequency factor, and how it can be computed? So it is dependent on YT. YT is nothing but it is a reduced variate. Also we need some correction in this, and for that there are two parameters, that is, one is reduced mean. Okay, if the sample is of large content, okay, sample is large, then at that time this reduced mean, it's a parameter used in this relation, that is equivalent to 0.577. so this value you have to directly put here, YNN. And then if we talk about SN, then this is again a reduced standard deviation, and for if the sample is of very large size, then SN value, how much we will take, that is 1.2825. so now you got the idea that what should be the SN value, what should be the YN value, and now what left, that is YT. And this for YT, what we need is that minus ln, that is a relation. Okay, this is a relation given to us. So how we can, like, if we are saying that we are having what was any return period was given to that question, any idea?
50 years.
Yes, it was given 50 years, right? Assurance that structure will not fail in the next 50 years. So but this is not a return period, Ashish. Okay,
Oh,
this
sorry.
is not a return period. Return period will be like we have to compute the return period, because it is just a number of years it is saying. It is not saying that whatever the data we have, whatever the return period we are looking for. Okay, that is basically return period. If you are looking, then that should be come up from the this flood data. Okay, flood data, it should come with that. So for computing the return period, we will use this this particular concept called reliability. Okay, so here we are provided with the reliability. So reliability is how much? That is 90%. So 90% in the sense what? How much it is? 0.9, right? So do you know the formula for reliability? How we are computing that? Risk, you may be knowing that. Okay. Wait a minute. Let me add one more slide. Wait a minute. I'm adding. Yeah. Okay. So I'm saying that reliability is just opposite of 1 minus risk. Okay, got it? So
Yes.
what is the formula for risk? Have you solved any question yet? 1 minus p to the power n, is it? Okay, and then if you are taking a 1 minus of this, then how much it will left? It will be directly 1 minus p to the power n. Am I right?
Yes, correct.
Okay, so now we are having a reliability value of 0.9. Okay, and then we also have a number of years. We want this structure to work in safer side. So that is n. That n what it was given for 50 years. So this is not a return period. Why it is not? Because return period will be taken out from the data. Okay, so here this n is 50 years. For the period we want this structure to remain safe. So now you have idea related to n. So now compute this p value. Once you compute this p value, once you get the value of P, then P has a relation with return period in this form. So from here you will get an idea of T, and this T will be used in YT, that is ln what was the relation, T minus 1 upon T, am I right? So from here you will compute the YT, and this using this YT, using this YN bar and SN, these three parameters, you will be computing a K value, and that K value will be directly used in the formula called xt equal to x bar plus K into sigma. Do you got what I just want to say? What is the procedure of going through this problem? Ashish, any problem, any difficulty in this?
No.
Wait a minute, let me bring Kelsey. Do you have Kelsey at present?
Yes.
Okay, then solve it. I am also bringing my.
So we need to take log both side, I think, to calculate this one.
Ashish, tell me the value of P. Balamurgan, you also solved the problem in parallel.
One minute. 0.9. Log.
If you don't have an idea that how we should approach this, then you can simply take a log of this.
Yeah, I'm taking log.
Then take a log of this. So ln, that will be in terms of, now it could come in multiplication. So n, and then ln 1 minus p. So using
Yeah.
this you can easily solve this.
50 ln 1 minus p.
Yeah.
0.9.
How much value you are getting for P? ln 0.9, how much it is coming? It is coming of nearly minus 0.1054 divided by 50. That is coming or nearly to minus 2.11 to the power minus 3. Okay, now this is equivalent to ln 1 minus p.
Just 1 minute.
E of okay, now I am getting 1 minus p equivalent to 0.99789 something. Then if I am taking 0.99789 e, then how much it will come? Okay, then to the power of minus 3. much you are getting value any?
No, no, I didn't get. So log 50 log 1 minus p. What is the next step you have taken? That is one.
What? Just I have taken out the ln log of 0.9. Okay.
That is minus 0.105.
Yes, and then I have divided by 50. Okay.
Okay, you directly divided by
Yeah,
50.
divided it by this value. Then what I did, I have taken the exponential power because that is a ln na. So how it will shift? It will shift in form of e. So e to the power of what much? How much value you are getting directly here? After
Uh,
computing
can you
this,
can you clear this one and you can write the next
yeah,
step?
yeah, I am just doing again. Wait a minute.
I got it minus 2.107 to 10 to the power minus 3.
Yeah, see the how much you are getting?
For log 0.9 upon 50, I'm getting 2.107.
Okay, so ln, tell me ln value 0.9, ln value you are getting minus somewhat
Okay, this ln I'm getting zero point 0.9.
10536 something, this much of
Yeah,
value
yeah.
you may be getting. Now divided
Hmm.
by 50, yes?
Yes, correct.
So now if I
So,
am dividing it by 50, so I am getting minus 2.107 into 10 to the power of minus 3. I am getting this
correct.
value.
Yes.
Now, now what, how much it will be equivalent? This will be equivalent to ln 1 minus
1
p now.
minus p.
So
Yes.
now in order to remove this ln, it will shift it here. So it will shift in form of e. So e to the power of minus 2.107 into 10 to the power of minus 10 to the power of minus. Okay. Now solve this value. So
1
if
minute.
you are solving this value, you will
So
be
now
getting,
it is 1 minus p e to the power minus 2.107 into 10 to the power minus 3.
yes, 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 e to the power,
Uh,
yes. So now
okay.
after solving this, you will be getting value this much, 0.99789.
1 minute, I'll check it. Exponential of
Let me check Balamurgan what he is doing.
10 to the power minus 3.
Okay, so T, yes, you are getting that's good. 475, yes, it's coming like that only, right?
So
Brilliant,
I'm getting
Balamurgan.
0.99
Yes,
e is
0.99
0.99.
something, yes, right.
Then we need to add it into 1 plus. No, it's
1
minus.
minus, you need
1
to
minus.
subtract
Yeah,
that,
yeah.
yes,
Yes,
1
yes.
minus
1.
0.99 something, and it should be coming in form of minus 10 to the power of minus 3. Okay, and
Yeah.
now after that take a reciprocal of that because we want t, and t is what? It is just a ratio of 1 upon p. Okay, I am
Just a minute.
just showing you that whatever the
I got
calculation.
p value as 2.104.
P value, how much you got?
2.104 into 10 to the power minus 3.
2.304 into 10 to the power of
104. 2.104
into 10 to the power of
minus 3.
good. Now take a ratio of this because we using this formula p equal 1 by t. Okay, now take a ratio of that. So you will be getting t value and tell me the t
Okay,
value.
okay, okay. So we need to take ratio of this one.
Yes, in
So
order
we
to
got,
determine
yeah, we got 2.104. Sorry, 1 475.
475. Yes, Balamurgan also got the same answer, 475 years. That's good. Okay, now you got the idea of t. Now what is next step is that you have to compute yt, and how you can compute this using this empirical relation minus ln of t minus 1 upon t. So firstly compute this value, then take a ln of that, and whatever value you are getting take a ln again.
So yt is equal to ln of t minus.
Minus ln of ln.
Oh,
Let me write it clearly. Okay, wait a minute.
uh,
You got this. Ashish, simply use this relation. I'm just showing you in this. Yeah, see here, it is mentioned here, YT. Compute this relation directly. Okay.
That is equal to ln ln
This is an important question. Okay, based on this question and based on this concept, you will be able to solve other problems also.
mm.
So if I am also computing this, so ln of ln, then it should be 475 minus 1. Sorry Ashish, whatever the relation I was just mentioning, it is not in that way. Instead of t minus 1, t minus 1 is coming in a denominator.
Yeah.
Keep in mind.
6.16, I think 6.16.
Okay, I guess Balamurgan also got the same answer. Match with that.
Yeah, he got same answer.
Yeah, that's good. Now compute the k value, taking a coefficients of other parameters yn and this sn.
Right. Where is the
Those are
formula?
the reduced variate.
So we got YT. K is what is the formula for K?
K. This is this formula you can see here. Wait.
Uh,
Yeah, this one.
no, it's not visible.
Not visible. Wait. You can see here also. Here. This one. Are you able to see here?
Oh, YT minus Y. Okay.
Yeah.
YT minus Y bar
But
N.
pen is not working in good way, so that is a
So
problem. I am not able to
YT
see.
is 6.16. What is Y bar N?
Yes, that are the reduced variate. Wait a minute.
Reduced.
Yeah, see here na. This one yn and sn and see the values. So yn bar is reduced mean and that value is taken as 0.577. See here, that value is given here only. Directly it is
But
given
for
here.
this question, we have to take same values or because the parameters are different, I think.
No. The concept is same. Why we are taking this this direct value directly? Because the condition here is that the sample, that whatever the data we are given, it is of large size. Here it is mentioned. Assume that the sample size is to be very large, and whenever it is large, then it can be considered as an infinite. And for that case only, this relation have been given. That see here, for n tending to infinity, we will be taking yn bar as 0.577. Are you getting?
Okay. So for every question, we can take this
Yes,
values.
but it should be condition should be like that the sample size should be in infinite terms. Okay, but if it is not given, then you like there are some procedure from where you need to compute this yn and sn also. Okay. But in most of
Okay.
the cases, while you will be solving these problems, you will be getting a sample in infinite size only. So you don't need to worry about yn and sn.
So I'm getting it 4.354.
Okay, so you are getting k value as how much?
4.353.
4.353. Match it with Balamurgan. Has he made?
Yeah, it's same. It's same.
It's same. Okay. So you got an idea of k. Now using this relation, xt equals x bar plus k into sigma n minus 1. So sigma value you already have. You already have a mean value of that. Now you got the k value and try to compute the xt. So that xt will be a design flood value for that structure. Tell me that value.
X bar we have.
Yes, x bar is how much? It was of around yes, it was around 1000 meter cube per second. And then standard deviation was given 500 meter cube per second, and k value you already got. Now tell me the xt value.
Can I see the formula?
Yeah, you can see the formula. Yes, just a minute. Yeah.
So, yeah. Okay, we have
My eraser is not working.
sigma n minus 1.
Yes, it is now working.
We have calculated sigma n minus 1.
So are you getting?
What is the value of sigma n minus 1?
Sigma n minus 1 is 500. See in this question. This
Okay,
here.
okay.
Wait a minute, wait a minute. I am erasing everything.
But is the okay? But standard deviation is 500, I think. Sigma is 500.
Yes. Wait a minute, Ashish. Wait a minute. Wait a minute. I am erasing everything. You can have a better look in this.
Yeah.
Because erasure is not working. That is the problem.
So
Yes.
sigma is 500, na?
Yes. Sigma is 500. Yes. Sigma is
Then
given here 500 meter cube per second. And then you have mean value, that is x bar, that is 1000 meter cube per second. And you got the k value directly with you. And then use this formula, xt equals x bar plus k into sigma n minus 1. So sigma n minus 1 is nothing but it is a sigma only.
Okay.
Tell me the value.
3177. 3177. I'm getting.
3177 meter cube per second, right?
Yes.
Okay. Balamurgan also got the same or somewhat different value?
We get same answer.
That's good. Okay. Brilliant. So actually the problem was what, that for this question I forget to add the slides. Okay.
No issue.
This is like good that we already solved this with our discussion only. Okay. Now we are moving to the next question. So this question is related to a rainfall data. So we are having annual rainfall data record at a station. Okay, so a station would be a rain gauge station. So here annual value, you can say that is a mean average, that is a average annual rainfall. Average annual rainfall value for every year is given. For 1980 it is given 360, then 1981 it is 332. Okay, and then likewise it is going for up to 2002. Okay, got it? So can you have any inference from this data? Just looking at the data between the annual rainfall and the year, what kind of relation do you have in your mind at just now? You are seeing the time series that in 1980 it is going continuously, it is rising. Okay, it is rising till 2002, and at the same time rainfall values you are also seeing. What kind of scenario you are expecting in the region?
The rainfall is decreasing.
Yes, then what could be the possibility? Like what kind of scenario may exist if rainfall is decreasing? What kind of thing, like if you are a hydrologist, what kind of prediction can you make if such kind of decreasing trend is observed in the station? So you are observing this kind of trend, right? With the data, if I'm plotting 1980 to 2002, I'm seeing the downward trend of the data, rainfall data. Okay, and that is representing that yes, in coming few years there would be a possibility of water shortage, because if the rivers are not getting a sufficient amount of water, then what people will be doing? People will be extracting excessive water of like groundwater, and at that case, if we lost our that is a main wealth, okay, main resource of as a groundwater, then definitely there would be a scenario of drought, and at that time it will be more vulnerable to the society, okay, in every aspect. So now the question here asking is that We want to find out the probability of occurrence of an annual rainfall of magnitude 155 centimeter.
Can we
Okay.
take 2 minutes break?
Yeah, you can. Yes.
Sure, sure, sure. Coming
Yeah.
back.
Okay. Balamurgan, you are too fast. That's good. Good to see. Okay, Ashish, are you back here?
Yes, I am back. I'm back.
Okay. Okay. So here the question is, we have to find out the probability of occurrence of an annual rainfall of magnitude 155 centimeter is. Okay. So it is asking about the probability of occurrence. So whenever we are about to solve such kind of problems related to a rainfall, then we have to follow a method where we need to give systematic order based on the rainfall data. That should be in decreasing order. So the first thing is that this data should be arranged in, it should be arranged in a chronological order. That should be a reverse chronological order, I can say. That is a decreasing one. Okay, so we have to arrange that one, and then we have to give a priority order, that yes, this rainfall value is higher in this year, so this would be given to order 1, it should be given order 2, likewise it should be decreasing. So if there is a, if I'm saying that how many total number of samples you are seeing here, observation, how many observations you are seeing here, tell me the total number of this.
22, 23 and plus 1.
Yeah, we will take it. So 23 if it is having, so 23, this priority will be for a rainfall with least value, and 1 for what, for higher value, higher rainfall value. And then we will try to apply some simple empirical relation. Okay, and then we will solve the probability of occurrence of this annual rainfall. So see this table. So in this table you are seeing the column 1 and column 2 as the data which is given to us directly, and see the rank depending on its decreasing order. That is for sure you have to arrange. If this data for this question you are getting a direct arrange data, okay, there is no variation, like values are not increasing, sudden increase on the rainfall data is not here. So this data was already arranged, and in that case you have given a priority rank. Okay, so priority rank depending on the rainfall values. So this value was more high, so that is why this rank was given. And then likewise it was given for 2002, that was equivalent to 23 number of data was there, so least value have been given to 23. Then how we are computing the probability? So probability will be computed by using the relation like this, that is priority order divided by n plus 1, that is number of total sample and plus 1. You will be applying this and you will be solving for all years. Then the question was for probability. Don't look into this column, actually this is an additional column added to this. So whenever if you are having, in addition to this question, if one question may be in terms of like instead of asking for a probability, because you are computing the probability, but the question may be asking that you need to figure out the return period. So how you will be doing? You will be taking a ratio of 1 upon like a ratio of p only, probability, whatever the p value you are getting, take a ratio of that 1 upon that is a 1 upon p. So you will be getting a return period. Now the question was what? Question was related to a rainfall of 155 centimeter. So what could be the probability? Okay, now you have already arranged, sorry for this mistake, I just encountered this. So annual, okay,
So can you explain the fourth column?
okay.
Probability order, probability.
So using this m in the sense, put this value 1
okay.
upon 23 plus 1, so it will be 1 upon 24. Take a ratio of this, how much value you are getting. It should come up like this,
0.041. Okay, so n plus 1 is number of year plus 1.
yes, right.
Okay, then next is 22 plus 1,
Yes,
23.
so 2 upon 24.
I think 23. Okay, n plus 1 will remain always same.
Always same, yes.
Got it.
Got it. So compute for third also. So 3 upon 24.
0.125.
Round figure. It is it is round figure in two decimal
0.13,
places.
yeah.
That is why you are getting these values. Okay.
Mm.
For 4 also you are getting. I'm getting in direct calculation. I'm getting about 0.1666 something
Yes,
value.
yes, yes,
So
yes.
it will be rounded in form of 0.17. So now
Mm.
you got an idea. Okay. That
Mm.
if you are having an annual rainfall series data, annual data, and you can compute directly this probability. And once you can compute the probability, if in question it is asking related to the computation of return period, then you can use the last column. Okay, this
So
column.
how the last column is calculated? It
Just
is
taking a ratio that is 1 upon p, because just we discussed in the earlier question now, that is p equals 1 upon t.
the return period.
This
One
relation
upon
is
two.
used. So for computing the t value, you need to take a 1 upon p value.
Hmm. So 24 means what? What does it mean?
It does mean that this, if you are talking about this particular of annual rainfall, so it means that the annual rainfall of 360 mm can, or like, it may or may not exceed within 24 years of period. Okay, so for 24 years you are just taking a probability that this much of annual rainfall won't occur. If, because if it is
Okay.
occur, then that structure, whatever the structure you are going to design, it may have, like, it may have a risk associated with that, because it is not going
Hmm.
to sustain that much of rainfall in, because whatever annual rainfall you are seeing, okay, that every rainfall is associated with the intensity. Okay, so volume of water will be more, and in that case that structure won't sustain that much effort, right?
Hmm. Got it.
Okay, so now the thing is, that is, that last column is for your additional knowledge, but question is still missing, like we are just lacking whatever we are about to target. So here the question was probability related to 155 centimeter is. So see, in the entire question, now we need to see the two columns, that one is annual rainfall and then another one is probability. Question is asking that we need to find out the probability related to 155 centimeter of rainfall, but in the entire series you are not getting any kind of data, that is 155. Okay, so if there is no data, direct data is available, then what you need to do is that take a linear assumption that these two data are correlated linearly. Okay, so that means that they are following a linear fit kind of okay hypothesis. Okay, this rainfall, if I am representing here as probability, and here you are seeing that rainfall, then both of these parameters are correlated with a linear hypothesis. Okay, so linearity is there. Okay, so considering this, that they are following the linear straight line fitting method, so this interpolation technique can be applied, linear interpolation technique can be applied directly. Okay, you can plot this data also, you will be encountering this only, because whatever the probability is being computed here, it will follow a straight line only. Okay, got it, Ashish? So here you have one value is 160, then another one is 150, and 155 will be in between them. So now you have to use this equation,
Okay. 150. Okay. We got in between the values and then we
and
need.
yes, so you need to find out the value between them. That is the
Okay.
question. So here you can
1000.
see here, if we use this relation, that is y minus y1 equal to y2 minus y1 upon x2 minus
Minus
x1.
x1, yeah.
Okay, that
No.
is x minus x1. We already solved this kind of question earlier
No.
based on this linear interpolation. So what was the response from Balamurgan? How much answer he got?
He got 0.521, I think.
Ah, that's good. Okay then. Okay, just I'm going ahead. Ashish, shall I move ahead now?
One question again.
Yeah,
From
slowly.
this, I can take away that in order to calculate the return period of more years, you need larger data.
Yes, right. Exactly. The
Yeah.
confidence will be more. If you are having a large amount of data, then you will be deriving a confident data, confident outcome from that.
So if we from 19, suppose 22 year only, we can calculate up to 24 years.
Yes,
In
right,
in order, if we want to calculate for 50 years, we need more data.
right. Yes, exactly.
From this data, we cannot derive the return period of 50 years.
Uh, Return period of 100 years.
From this 22 years, we cannot derive.
I guess in that case, if you want, you need to just extrapolate. You can compute, you can compute it. See,
Okay.
I just want to mention that if it is linearly establishing the relation probability and rainfall, then you are interpolating, right? Between these values, you can directly assess these values, right? But if you extend this line for further data, okay,
Okay.
then you can also get an idea related to a return period of more than whatever the data you have, like after that range also.
Hmm.
So you, what
Probability and
you,
by using probability formula.
yes, you can get, okay,
Hmm.
like see,
Balamurgan has also answered this question. He says
what
Balamurgan also answered this question. He says you can do it with the semi-log will get straight line.
yeah, yeah, yes, exactly. So extrapolation is a technique you can use in this question also, and then you can extend that graph, and directly you can get the value of your desired return period.
Hmm. Got it.
Oh, okay. We can do with the probability paper or log plot. Yeah, yeah, right. Plotting can be done with this. Yes. Yes, that is a Webu's formula. Yes, right. Okay, okay. You got value how much? Okay, probability of this. Okay, descending order, rank them. Yeah. If I take P equal to M by N, then 5. Yeah, right. Yes. I found like in most of the problems, I found that people mostly prefer Webu's formula in most of the cases while we are dealing with the extreme kind of events. So yes, of course, this formula can also be used, P equals M by N, right? Okay, now I am moving ahead to the question is that, okay, now this question is same, just the only thing changed here is that return period is known. See, now in this question return period is whatever the question we have just solved in the previous question. So return period is known to us, that is given 20 years. See, 20 years that is given, so t value is given to us, that is 20 years. Now what we need to find out is that annual rainfall corresponding to 20 years. So now again you need to use interpolation method. So t is known to you, so this 20 will fall between 24 to 20, right?
Hmm.
So now you will be using interpolation between these two values, and then again annual rainfall will be used for corresponding to t values what you are having. So t for t you are having 24, so for that case annual rainfall is 360. and another value for T equals 12, then you are having annual rainfall of 332. Then definitely for 20 years this annual rainfall will lie between 360 to 332. Okay, and then the value came here is 351 centimeter of rainfall. You can compute it using this formula only, interpolation method. Ashish, any confusion?
No.
Okay. Okay, now we are having question related to annual flood series only. So here again the data, whatever the data we solved in that question also, it is nearby to same. So see, tell me what are the data we have. Tell me.
We have the annual flood of river is 600 meter cube.
See, mean value is given.
Mean value, yeah.
So x bar is
X
given to
bar.
us, that is 600 meter cube per second. Then what next data that is given?
That is standard deviation sigma.
Yes, sigma is given, so that is 150 meter cube per second. That's good. Then what is the probability it is asking? So P we don't know, but we also know that there is one relation between P and T. So P, for time being we are establishing that relation. So P is always equal to 1 by T. Now what next data have been given? So question is being given that probability, the question is asking that probability we need to find out for the target flood of 1000 meter cube. That means xt is given here. Target value, that is a design value we can say. Okay, so they want us to compute the probability of flood of magnitude 1000 meter cube per second. So that is what? That is a target value. Target value for that return period, you can say. So 1000 meter cube per second is given, and this n number of period is also given for, like, what is the number of year. So number of year is given 5 years. Okay, so how we will approach this? So we will approach by using the equation given by Gumbel's method. So xt equals x bar plus k into sigma, right? So we already have information related to x bar, that is a mean value. Then we already have information related to sigma. Now what left? It's a k value only left. Also we have xt. So tell me the value of k. We have three values to us, like it is given to us.
K is equal to yt minus.
No. K should be computed directly from here. Okay. You are discussing for further things. Okay. So K will be equivalent to yt minus yn upon Sn. Okay.
Yeah.
It was the relation. Now the question was asking is that probability we need. But in this entire question, in this entire method, you won't find a term called probability directly. You won't find that, because this question is totally based on the return period. So everywhere you will be finding a parameter called t, right? Once you compute the value of t from here, from this Gumbel's method, then you will be taking 1 upon t, and that will giving you a direct value of probability. Any doubt so far? See, in the question it is mentioned that sample size is very large. That means yn and Sn value, they are fixed. That was given to in that slide, that was given, it is fixed. Then what left? That is yt is left, right? So can't we compute yt from here, knowing that k is given to us? K can be computed from here now. Ashish, tell me the value of k from here. Firstly, tell me the value.
So xt, what is the value of xt?
Xt is given, na? Xt is the target value. Target is what? We are targeting a flood of magnitude 1000 meter cube per second. For this we need the probability. So this is the target value. So keep xt as 1000. Then x bar is given to you. X bar is how much? 600.
600.
And sigma is given to you. That is 150.
Sigma is 150. Okay. Yes. A into 150.
So how much
Copy.
K you are getting?
1 minute. 400. 2.66.
Okay, so you are getting 2.66. Good. So you got the value of 2.66 or maybe 7. That is equivalent to YT minus YN bar upon SN, right? Now you have a fixed value of YN and SN. What are those values you can take from here?
1 minute. YT minus YN bar upon SL.
Okay, YT equals 4. That's good. YT is coming 4. We can do. Okay, okay. Yeah. So Ashish, take the value of YE, YN and SN as 0.577. It is mentioned here.
Hmm.
Yeah, this one. This last line you can see.
So YT is equal to 4.
You got that value, YT.
No.
Compute that, na?
Oh, I have to apply this formula.
Yeah, this one,
YT.
this formula you have to apply. You already got the K value, that is 2.667. Then SN value you already have. Compute the YT value.
YT value is V is YT, yeah. Minus log or log of TT minus 1.
No, 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 no.
I got
For
confused.
time being, we are directly computing the YT. YT value will be coming directly, numerical value. It will be coming from here, from using this equation.
Okay, sorry.
Provided YN and SN is with you. This is these values. Use these values, na?
Hmm.
YN SN is given this. So use this value here and compute YT using K value. K is given
Got
2.667.
it, got it, got it.
Wait a minute, I'm also computing.
2.667 into SN.
Okay, I'm also getting somewhat 4 value. So Balamurgan is right. Any confusion? Ashish, are you also getting this answer? Take your time, no issue.
Yeah, I'm checking.
Yeah.
2.667 plus YN into SN. Yeah, I got YT is equal to 4.
That's good. Good. So now you got the value nearly 3.9970. That is the 4. And now equate this with this formula. Minus ln t upon t minus 1. From here you will get an idea that how much t is coming.
Hmm.
Got it?
Okay.
So see, t is coming nearly to 55 years.
Hmm.
Things are very similar, whatever we did in the earlier problem. So here for this question, t is coming to be nearly 55 years, and see how the probability is computed. Probability of occurrence of a flood of magnitude this 1000 meter cube per second. That is what that was a target flood. So how it come? It is p equivalent to 1 upon t, and that is 1 upon 55 comes to be 0.082. Don't go through this. This is a part of computing a risk. How much risk is associated? Okay, so this is a part of risk, but question is being asked to compute probability. So probability is this much. in percentage you can also compute it, will come up to 1.8%. Am I right? Ashish, are you computing?
Yeah, I got it. 0.0182.
That's good. Yeah, okay. So see, this question, whatever the question you are looking at, the last line is related to risk.
Yes.
So
Yeah.
this is the formula for risk. If you know the idea, if you have an idea that probability, see Ashish, whenever the question is given to you, you should directly correlate the what are the relation establishes with these parameters. If the question is given that probability is given, okay, then directly your mind should click in that way that yes, P is always equivalent to 1 upon T. So in that terms, you can directly get an idea that how this question should be approached. Okay. So I am skipping this question right now. We can discuss it in the next class tomorrow, but I am just adding one or two questions related to risk. I hope it is here in this question, in this slide only. No. Okay, so those questions will be in the next part. But okay, just for your information, I just want to take this question. This question is more related to the what the problem we already did. So see, the question here is given. The estimated maximum flood for return period of 150 and 50 years using Gumbel's distribution are this and this. Got it? So I am just taking, I am separating these two events in two different cases. So case 1 you can say and case 2 you can say. Now tell me what are the data we have. So we have maximum flood. So maximum flood, take it as a target value. So that is xt. So xt here is given, that is 2600 meter cube per second. And what was the return period? So return period for this is 150 years. Got it? Now for the second case, xt is given, that is a maximum flood is given, that is 2000 meter cube per second for time t, that is t is the return period of 50 years. Got it? Now the question asking is that find out the maximum flood discharge, that is xt max again, for t equals 200 years. This is the question. Now I just want you to just tell me that what should be the approach, like how we can approach this question. That is the thing I just want. See, xt max is asking, right? Right? Am I right or wrong?
Yeah, right.
Yeah. So xt max using Gumbel's distribution can be computed by using what relation? What is the relation for that? Just you solved in the earlier problem. What was the relation? What was the relation for xt?
X is equal to x bar plus sigma k.
Yeah, k into sigma. That's brilliant. Good. Now see Ashish, if I am taking it for first case and I am taking it for second case, I am taking it for second case. Now from both these equations, xt is known, right? X bar is not known, right? Yeah. Then k is also known. K is known or not known? Tell me.
Right.
K is known to us. How? Because k is dependent on
E. So E is dependent on.
yt minus yn bar upon sn. Since we just I mentioned that since k is dependent on t, and t value is given to us in both the cases. So I'm just writing this equation that k is equal to yt minus yn bar upon Sn, right? Am I right?
Yes.
Now
Yes, sir.
yn can be computed easily, and yn bar and Sn value, you know, these are fixed values. So you have these values. Now what left is that yt. So you don't have a direct value of yt. So how you can compute this? So you just need to solve this by using this empirical relation, minus ln
T upon T minus 1.
t minus 1, right?
Yeah.
So you for case 1, see, for case 1, what is the t value you will put? You will put 150 here, and then denominator will be 149. Then accordingly you can get the yn value. Once you got the yt value, okay, this will be yt value. Now yt value is given to you. Yn value you already know that those are the coefficients. Sn value you already know. You can directly get the k value. Can you get this value? Can
Yes.
you get this value k? Any problem so far?
No.
Things are clear, na? You can
Yes,
ask
yes.
me. Steps
Yes.
I am just reminding you again.
Yeah. Clear now.
Okay, so k is known to you now. So for the first case, you got the value that how k should be computed, right?
Hmm.
Can't you compute the k value for second case as well?
Yeah, we can use same equation formula.
Yeah,
and
fantastic, good. So once you get the k value for both the scenarios, your equation will look like that. I'm just showing you in the next step. So see, the given data is given to us, like whatever the data is given, it is directly mentioned. Then using Gumbel's equation, what is the empirical this relation given by Gumbel distribution. So now see the case 1. So maximum flood, that is a Q max, it is given that 2600 meter cube per second is existing at a return period of t equals to 150 years. Then see yt have been computed, and then yt value after using the yt, this how much yt value was given, like it is computed. So it is computed directly as 5.0. Now this yt have been used in k, that is the frequency factor, and k value, how much k value was got? It was got 3.45. Now see the equation. Just this I am whatever the process we discussed so far is that coming to this step. So this is the equation you will be getting in final for the case 1. Any doubt so far?
No.
Yeah. Okay. Now switching to the next case second. So see, case second, it will be following the similar procedure only. Yt you can compute. You will be getting yt using this relation. Then value will be 3.90, and then you will be putting this in frequency factor. So for finally you will be getting 3.50. 59. That is 2.6 you can say. Okay. So you got the value k as 2.6 for second case. Now see the relation. This equation you can get. Any confusion so far?
No.
Okay. Now you got two linear equations, and you better know that how we can compute the unknown two parameters, because now we have what are the unknown parameters? Tell me. What are the unknown parameters in both the equations? One is x bar, that is a mean,
X bar, yeah, X bar.
and the
yeah.
another one is standard deviation, that is sigma. Standard deviation. Now for these two unknown parameters we have two equations.
Now we can calculate. Yeah.
Then using a substitution method you can directly compute these unknown parameters. So x bar, how much we got? That is 193. Then the for standard deviation, how much we got using these equations only? 697 something we got. Now see that what was our target. So we were having a target of return period t equal to 200 years, but we were about to find out q max. What would be the q max at return period of t equal to 200 years? See, the relation we already got. This is a relation, see, xt. So x bar is given to us, like we already got this value x bar 193, right? So see, this equation is using 193 because now the data is same. Whatever the mean value and standard deviation you are getting, that is same for this this scenario as well. Sigma n minus 1 you already got, that is 697. So here it is also mentioned. Now what left? that is a K. Because once you get the value of K, you can directly say that yes, this is the maximum flood value can be possible. So how you will get the K value for this? So since you are getting a return period of T equal to 200 years, you need to again repeat the process of computing frequency factor, where you need to find out Yt using relation minus ln T upon T minus 1. Right? So here in this case you are getting a value of K that is 3.68, and after substituting the K value, you are getting a direct value of somewhat nearly 2700 meter cube per second. Any hard and fast method, like like I don't think there is more difficulty in reaching up to here. Just two cases were given, so those cases were only given in order to give you an idea that yes, those two unknown parameters should be known to you. Once you got those unknown parameters, you are coming back to the target problem. So this was the target problem, where it is asking that return period is given and now you have to compute the maximum flood. So in this case, x bar, whatever the value you got in earlier calculation, you have to substitute here, and then standard deviation you have to give. Likewise, you have to compute the K value, that is the frequency factor, and then at last you can compute the value of xt. Any difficulty, Ashish?
No.
Okay. So I guess 2 or 3 problems are still left. There was some issue in the starting, so that's why I just started with some time lag. Okay, Balamurgan is saying that yeah, 1/54, that's good. 1.85%, yes, good. So Balamurgan, I hope you already got the problems. There are few problems still left. Just when we start solving the problem during the session itself, it get there is some time constraint always exist. So I will try to cover those questions. I guess 2 or 3 problems are left. Okay, and then there will be some problems in the next session related to risk and reliability, because those are the more frequently asked questions. Because when we are dealing in the field problems, then the first query that come in the normal people or maybe a stakeholder, that how much this structure will reliable. Okay, will it affect to us in case of monsoon period. Okay, you may be having some kind of reservoir policy problem related to Sardar Sarovar Dam, which is existing in the river Tapi, okay, connecting Madhya Pradesh and Gujarat. So there is always a water distribution problem, that how much water should be, because in one event what happened, that there was a surplus amount of water during I guess 1998 or 1997 year. Excessive flood was there in that case. So that reservoir is told that now this much of surplus amount you can't hold, you have to just release that water. So in that case, in order to make it reliable, water have been spilled out, and then whatever the people or local people, those were the villagers, so people were residing in the downstream part, they all get submerged. So that in that case it was in news that maybe nearly somewhat I guess 300 to 300 people, 50 people have been died in that case, and some people have lost their livelihood at the same time. So when we are dealing with designing any kind of structure, hydraulic structure, we should have some confidence that it should not affect the local community as well. Okay. So today I will stop here. any problem so far? Anything to discuss?
No, thank you.
Okay then. Yeah, thank you Balamurgan. Thank you Ashish. We will meet in the next session. Okay?
Yeah, we had a next session tomorrow, same time. I think.
Yeah, right. Yes. Exactly.
Okay.
Okay, actually just what I was just requested from NPTEL side, because I just mentioned that I will be boarding a flight on 11, so in order to make it clear the things, like it won't be possible there na, in order to
Yeah, yeah, yeah.
take classes, so that's why I just preponed these classes. Okay.
Sure, sure.
Yeah.
Yes.
Okay then Ashish, we will meet tomorrow. Okay.
Sure. Thank you.
Yeah, till then, bye.